Mean, variance, and standard deviation for a binomial distribution. Let's recall from an earlier video, we have already calculated mean, variance, and standard deviation for a probability distribution, and at that time it was turned out that the computation was a little difficult and more involved. But the good news is, this time when we have a binomial distribution, when we are dealing with a special type of a distribution called a binomial distribution, the computation is way easy as compared to the previous calculation. We have a simple straightforward formulas, and with the help of these formulas you can very easily compute these things very easily. So let's start. First, what we have the formula for the mean. It's represented by mu. Mu is equal to n times p, and this mean is also called the expected value of x. I will explain you what I mean by the expected value, mean. Right? The variance is defined as n times p times q. This dot is a multiplication, and it is represented by a symbol sigma. This is a Greek symbol, sigma square. That's the variance. And what is the standard deviation? Standard deviation is nothing but it's a square root. It's a square root of the variance. You take the square root, you get the standard deviation. N times p times q, taken the square root. That's a sigma, which is the standard deviation. But let's first understand what are these symbols here. N. What n stands for? N stands for number of trials. Right? In a binomial experiment, n stands for number of trials. What is the p? P is the probability of success. And what is q? Q is the probability of failure. So these are the things which you need to know, M, P, and Q. And I hope you remember that Q is always equal to 1 minus P, or some people also write it like this, P plus Q is always equal to 1. Whatever the case may be, you can very easily understand that. So these are the three formulas which you need to remember, and then by plugging these values into these formulas, we will be easily able to calculate mean, variance, and the standard deviation. How we are going to do that? Let's see an example. Here is the example. The probability that a football game will go into an overtime is 10%. In 80 randomly selected football games, find and interpret the mean and the standard deviation of the number that went into overtime. Right? So we have to find what is the mean number of games that went to an overtime and what is the standard deviation, right? First, what we are going to do, we're going to write the formulas, what we have already seen, right? What is the formula for the mean? Mean is represented by mu, and that is always equal to n times p, right? So let's see what is n here and what is p here. N stands for the number of trials. We have selected 80, we have randomly selected 80 games. Each selection of a game is called a trial. So the n is 80. And p is the probability of success. What is the chance that our game will go into an overtime? That is 10%. This is 10%. So the probability, the chance that our game will go into an overtime is 10%. So this p, the probability of success, is 0.1. So you plug in here the values, you will get the mean. Mu is equal to 80 times 0.1, 0.1, and it's a simple calculation, it's 8. So mu that comes out to be 8. This is the mean. This is the mean. And this is also called the expected value. Why this is called an expected value? Because this is the value that we can expect. It means, what does this mean? What does this mean in this situation? We can expect that out of these 80 randomly selected games, 8 of the games will go into an overtime. These are the number of games that we may expect to go into an overtime. And that is the reason that we call the mu as an expected value. That's how you compute the mean. Now let's compute the variance now. Let's compute the variance and recall the formula for the variance. What is the formula for the variance? You remember the formula for the variance was sigma square was equal to n times p times q. Now p was the probability of success. So what will be q? Q is the probability of the failure. So Q is equal to, if there is a 10% chance that our game will go into an overtime, it means there is a 90% chance that our game may not go into an overtime. That's the idea of the probability of the failure. So you plug in the values here. Sigma square is equal to 80 times 0.1 times 0.9. You can do this computation on a calculator. Let's see. So we have, this is a desktop and online calculator. You can use it very easily. So we have 80 multiplied by 0.1 and it's multiplied by 0.9. So it's it turns out to be 7.2. So our answer for this variance comes out to be 7.2. So we have found the mean and we have found the variance now. It's the variance. And what is the standard deviation? Standard deviation is nothing but it's the square root. It's the square root of the variance. Just take the square root of this one. So you have sigma squared, take the square root here. It's equal to n times p times q. Just take the square root of this number. So it means just take the square root of 7.2. Take the square root of 7.2, you will get the variance. Let's do that on a calculator. So you take the square root of 7.2. The answer is 2.68. So our answer comes out to be 2.68. So our standard deviation is 2.68. So we have found all the required values. We have found the mean. The mean is 8. This variance is 7.2 and the standard deviation is 2.68. I hope you understand this calculation. Thanks for watching.